In this video, we explore the line optimization tool that was developed by Mark Pelczarski. The tool itself is very easy to use. Its great value is in demonstrating visually how changes to polling place resources affect wait times. The Pelczarski tool also has an extensive set of help menus. If you go to the right-hand side of the screen and click on Help, you can get a lot of information and documentation about the simulation, simulation basics, the settings of the simulation, and information about loading your own data. In addition, you'll see in many places on the screen where there are little question marks. If you hover your cursor over a question mark, there's some basic information about the feature it's next to. So the simulation is quite well documented. Like any simulation, we need to enter in some information to perform the analysis. For the Pelczarski tool, the basic information begins with data about the polling place, when it opens and closes, how many voters will arrive, etc., and then some timing information about how long it takes to check in and how long it takes to actually cast a ballot. The Pelczarski tool allows you to explore even more things that affect polling place lines, but we won't cover those here. To see how the tool works, let's take as an example a precinct in a county where the polls are open for 12 hours on Election Day, from 7 a.m. to 7 p.m. There are 1,200 voters expected on Election Day. We plan on the average check-in time to be 1 minute, and it takes an average of 6 minutes to mark the ballot. Let's start with the data we would enter at the top of the computer screen. You'll notice that there are some pull-down menus and data boxes at the top of the screen where we enter some of the data. We can start by telling the simulation when the polls open. Next to the text that says "Poll is open," there are two drop-down menus we can use. We see that the opening time is already preset to 7 a.m., so we don't have to make any changes there. But polls close at 7 p.m. and the preset says 8 p.m. So I'll change that by clicking down and selecting 7 p.m. So we now have the poll open and closing times all set. You'll have noticed that just by changing the closing time, the visualization down below changes. That's one of the nice features about the simulation. You can change the information associated with the precinct, and you'll get immediate feedback. Now, to continue with the example, we want to change the expected voters to 1,200. We do that in the very first box up at the top, where it says Expected Voters. I'll type 1,200 in that box, and I'll hit the Enter key on the keyboard, and we'll see that the visualization changes quite dramatically. Finally, we need to fill in the number of check-in stations and voting stations at the top of the visualization. Let's say for the moment that we would normally assign 2 check-in stations and 8 voting booths to a precinct like this. You can see that 2 is the number of check-in stations by default, so we don't need to change that, but we need to change the number of voting stations. To do that, I'll click on the pull-down menu, select 8, and we see again that the visualization has changed. Now, we're not done yet in setting up this precinct because we still need to enter in the various times that it takes to check in and to vote. We enter this information in the boxes below the visualization. There's text that says average minutes to check in and a box right after that. We'll enter the number 1 here because that's what we believe the average check-in time will be, and hit the Enter key on the keyboard, and the simulation changes. We set the average amount of time it takes to vote in the box that's right next door. The default is 5 minutes. I'll change that to 6, and then hit Return on the keyboard. The data have all been entered now. Let's review what the visualization tells us. You'll see that there are different colored regions on the graphic. The yellow part of the graph shows the estimated amount of time it takes to check in at each 15-minute interval throughout the day. You'll see in this case that there's a little hump right at the beginning of the day and a bigger hump at the end of the day. The pink part of the graph indicates the average amount of time it would take to vote, depending on the time of day. This is added to the check-in time so that the overall height of the two regions together indicates the total amount of time it takes to vote, from start to finish. Let's now do some fine-tuning to the simulation to see what we need to do to get the wait times down close to zero all day long. We'll start with checking to see if, by adding one more check-in station, we could get the check-in times down to near zero at the beginning and end of the day. I go back up to the top of the screen, use the pull-down menu to specify 3 check-in stations. The visualization shows that I've accomplished my mission for check-in times. The pink part of the graph signifies when the long waits occur to cast a ballot, which is pretty much all day long, although things get really bad in the late afternoon. What happens if we add 4 more voting stations? I can answer this question by using the drop-down menu to select 12 voting stations for this precinct. With the change in the visualization, I can see that I was mostly successful, except for a long line that emerges after work. If we hovered the cursor over to around 6 p.m., the box in the upper left-hand corner tells us there is an average wait of about 28 minutes to vote. Let's see if we can get that down to zero by maybe adding 2 more voting stations to this precinct. And it almost gets down to zero. Add 2 more to go up to 16 voting stations, and the wait time really goes down to zero. Okay, so these are the basics for how to use the simulation to understand the dynamics throughout the day. I'll point out one more feature of this simulation that is valuable to play around with right from the beginning. To do that, I'm going to go back and reset the simulation to show how we started, where we have 1,200 people voting during the day, let's say the 2 check-in stations, and 12 voting stations. So we still have this little bit of a wait to check in at the end of the day. The feature I want to point out is the so-called arrival pattern, which is set by a pull-down box below the visualization. We know that different precincts have different arrival patterns throughout the day, even though they might have the same total number of voters who come throughout the day. For instance, there might be a precinct where there's a big rush before work, but not a big rush after work. Or there might be another precinct where the rush comes after work, but not before work. The Pelczarski tool helps us to visualize how the arrival pattern of voters affects lines at the polls. Now, the default in this simulation is an arrival pattern that's labeled as composite, which is based on some research that's been done in arrival patterns across many precincts around the country. We can think of the composite arrival rate as being a type of national average. If you want to see what the arrival pattern used in the simulation actually looks like, you can go down to the very bottom of the screen. See this little plus sign next to the text that says Show Simulation Settings? When I click on this plus sign, I get some text. Down at the bottom, there's a little box right next to the text that says Show Arrival Pattern. If I click on that box, now the simulation graphic has a gray line that actually shows the arrival pattern that's used in the simulation to generate the amounts that are graphed out down below. As I said, this is the average arrival pattern across many precincts. Let's say that we had good information about a particular precinct that we are analyzing from past experience. Our experience is that this precinct always has an early morning peak of arrivals, but that later in the day there is a smaller arrival peak. We can simulate a precinct with this type of arrival pattern by clicking on Early Morning Peak. We see that the gray curve has changed so that the big turnout surge is in the morning and a smaller surge is in the evening. As a consequence, the timing of when lines form at the polling place shifts. There's a long wait to check in for most of the morning, but not in the afternoon or evening. We could choose another option here called Saturday Steady, in which people pretty much arrive at the same rate throughout the day. When I select that, there's really no waiting any time during the day. Because voters arrive at a more or less constant rate, long lines never form, and a wait of more than a minute or 2 is rare. So there you have it. There's a lot here to play with, a lot here to learn, but the simulation is easy to explore because of the immediate feedback of the visualization.